Okay, these are rational functions that need simplified before graphing. So, for example, we're going to have to factor these and maybe get a common denominator if we're adding or subtracting. On 3a, it says simplify the equation and find any x-intercepts, vertical asymptotes, horizontal asymptotes, and undefined points for this function right here. Got to factor everything. The x squared minus 4x and x factors out. The x plus 7, you can't do anything with that. This right here, this x squared plus 4x minus 21 factors into x plus 7, x minus 3. The x cubed minus 16x, first of all, factor out an x, and you'd be left with x squared minus 16, which factors into x plus 4x minus 4. Now I'll start canceling some things out. The x cancels out with an x, the x minus 4 cancels out, and the x plus 7 cancel it out, so we're just left with f of x equals x minus 3 over x plus 4. To find the x-intercepts now, set the numerator equals 0. If you set x minus 3 equals 0, you get x equals 3. To find the vertical asymptote, set the denominator equals 0, and you get x equals negative 4. Looking at horizontal asymptotes, you look at the degree of the numerator and denominator. They're both to the same degree, so you look at leading coefficients then. So it's 1 over 1 or just 1. So it has a horizontal asymptote at y equals 1. So the limit as x approaches infinity for this function would be 1. The limit as x approaches negative 4 would actually not exist, because on one side it's approaching infinity, on the other side of negative 4 is approaching negative infinity, because there's a vertical asymptote there. There's also undefined points everywhere that the terms were completely canceled out. For example, x was canceled out, and where does x equal 0? Well, at x equals 0. So at x equals 0, there's an undefined point. And to get the y point associated with it, you just substitute the 0 in here. 0 minus 3 is minus 3, and 0 plus 4 is 4, so you get minus 3/4. So the point 0, negative 3/4 is an undefined point. X minus 4 got canceled out. Okay? So what made that equal to 0? 4. So 4 is an x value that is a part of an undefined point. To get the y part of that undefined point, substitute the 4 in here. 4 minus 3 is 1. 4 plus 4 is 8. So you get 1/8. 4 1/8 is another undefined point. X plus 7 canceled out. What makes that equal 0? Negative 7. If you substitute negative 7 in for x in the simplified version, you get 10/3. So there's 3 undefined points on this thing. So if it said, what's the limit as x approaches 0 on this, it'd be negative 3/4. What's the limit as x approaches negative 7? 10/3. What's the limit as x approaches 4? 1/8. So that's how you do those problems right there. And like I said before, the limit as x approaches negative 4 doesn't exist. The reason why is that, yeah, there's a vertical asymptote, but that's not the only reason. The vertical asymptote, it could have been that it's infinity, negative infinity, or maybe it doesn't exist. But since the exponent on the x plus 4 term is to an odd power, that means it's going to go in opposite directions. On one side it's going to go to positive infinity, on the other side it's going to go to negative infinity. So in other words, they're getting farther apart. That's why the limit doesn't exist. Okay? And here's a graph near that negative 4 showing, see, it's heading off to positive infinity on one side, negative infinity on the other side. So as you get closer to negative 4, the y values are getting farther and farther apart, so the limit doesn't exist. Okay, simplify this thing. Well, when you divide, you have to reciprocate it. So the first thing I have to do is reciprocate this second fraction right here, factor everything, and you get this, and then cross terms off, like an x minus 4 with an x minus 4. Notice there's still an extra x minus 4 left on the bottom. X minus 5 cancel out, and x plus 2 cancel out. Now, every term that's been completely canceled out, the thing that makes that term equal to 0 will be an undefined point. Now the x minus 4 didn't get completely canceled out, so that's not an undefined point. But the x plus 2 did, and the thing that makes that term equal to 0 is negative 2. So the x value of negative 2 is the x value of a undefined point. If you put negative 2 in here, negative 2 minus 4, it's negative 6 on the bottom, or 1 over negative 6. So this is an undefined point, negative 2, negative 1, 6. 5 makes these terms that got canceled out 0. If I put 5 in here, I get 5 minus 4 is 1, or 1 over 1. So 5, 1 is also an undefined point. So the limit as x approaches 5 is 1. The limit as x approaches -2 is -1/6. What about the limit as x approaches 4? Well, that's not an undefined point. That's a vertical asymptote because it remains in the bottom. So, and it's also to the first power, so that limit won't exist because it's going to positive infinity on one side and negative infinity on the other side. It doesn't have any x-intercepts because there's no x in the numerator. Has a horizontal asymptote of y equals 0 because the power of the denominator, the degree of the denominator, is first, and the power of the degree of the numerator is 0. So it's going to have flat line of y equals 0. And we might have a graph of that. Well, no, it's very similar to the other one in terms of that x minus 4 term. See, it's to an odd power, means it's approaching negative infinity on one side and positive infinity on the other side. Okay, how about this? For this equation right here, what is y approaching as x approaches infinity? Well, here we got 4. As x approaches infinity on this part right here, you would get 0 because the degree of the numerator is greater than the degree of the degree of the denominator is greater than the degree of the numerator. So that's going to approach 0. The same way with this. This is also going to approach 0 because this x plus 2 gets flipped to the bottom. So we basically get 4 minus 0 plus 5 times 0, which is 4. So the answer to that would be 4. And we have that right here, 4. Now for this equation, find any vertical asymptotes. Well, vertical asymptotes is where the denominator equals 0, and the denominator equals 0 at x equals 0 and also at x equals -2. Again, this negative exponent flips it to the bottom. To set these equals 0, you get x equals 0 and x equals -2. So there's 2 vertical asymptotes. As long as these values don't make the numerator equal 0, and there's nothing even to substitute the 0 and -2 into the numerator. So these are the location for the vertical asymptotes. X-intercepts are the hardest thing because you would actually have to simplify it. So here is the expression written out. You'd have to multiply this 4, right, as 4 over 1, and multiply the top and bottom by x times x plus 2 on the top and bottom. You'd have to multiply this 3 and also the x below it by x plus 2 to get a common denominator. And you'd have to multiply this by x top and bottom. So there's your common denominator, and here's your numerator, and then you have to FOIL all that together. It actually factors. If it wouldn't factor, use the quadratic sheet, and now you can get the different things. Like, for example, there's an x-intercept at -3, another one at 1/2 right here by setting these equal 0, and vertical asymptotes at 0 and -2 like we said before. So that's pretty much everything on that. On this expression, new one here, what is y approaching as x approaches infinity? In other words, what is the limit as x approaches infinity? On this, well, we got a 4 here. Here the powers are the same. So you look at the leading coefficient, and you get -3/2, minus from right here, -3/2. And here this gets flipped down to the bottom. Here it is written. So powers are the same. So you look at leading coefficients, which are 5 and 1. So basically we end up with 4 minus 3/2 plus 5, which is 7.5. On this one, what's going on here with this one? What is y approaching as x approaches infinity? In other words, what is the limit as x approaches infinity on this thing? Well, here's a 4. Here the power degree of the numerator is 2 and the degree of the denominator is 1. But when that happens, this approaches infinity. It really doesn't matter what this approaches. This is still 5. But 4 minus infinity, see, this is heading to infinity here because the power is greater on the top than it is on the bottom, plus 5 is still negative infinity on this thing. So this thing is heading towards, well, I say infinity here, but it's actually heading off to negative infinity on this. And looking at the next one here, for this function, given the location of any intercepts or asymptotes, well, this looks really messy, and the key thing here is that you have to factor out the like term. Like, for example, there's a common binomial on the top of x minus 3. Now, how high of a factor of x minus 3 can you factor out? Well, look at this review problem here. You said factor x squared minus x cubed. Common factor is x squared, the lowest powered term. Well, the lowest powered term with x minus 3 to the negative 2 and x minus 3 to the negative third, the lowest power on those is negative 3. So that's actually what you would factor out, is the x minus 3 to the negative 3 power, because it's the lowest power. And when we factor out the x squared, we say, okay, well, x squared divided by x squared is 1, and x cubed divided by x squared is an x. Now, how do we get that x? We got that x by doing 3 minus 2, the thing we're factoring out, the x squared. 3 minus 2 is 1. Okay? Well, the same thing goes on here. When you factor out that x minus 3 to the negative third, you're actually saying, well, what is negative 2 minus a negative 3? Okay, because you're factoring that out. Well, when you factor out, when you say what is negative 2, this exponent, minus a negative 3, well, that's the same as negative 2 plus 3, or 1. In other words, see, this power right here of negative 3 is 1 lower than negative 2. So this x minus 3 here, when you factor out the x minus 3 to the negative third, this one is going to be to the first power, because what you factored out was 1 lower than this. Just like here, you factored out an x squared, it's 1 lower than the x cubed. That's why there's an x to the first right here. So let's go ahead and do this problem. There's a common factor of 2, okay, because the 2x and the 8, there's a common factor of 2, and also there's a common factor of x minus 3 to the negative third. So that's what we need to factor out, the 2 times x minus 3 to the negative third. When we factor out that out of this part right here, we'll have a 2 and an x minus 3 to the first power. And that 1 right here came from, that's the hardest thing, that comes from the fact that this is 1 power bigger than this. And then over here, when we factor out that 2 times, factor out the common factor of 2 times x minus 3 to the negative third, the only thing left over here is 8 divided by 2 is 4. And so here now, simplifying the inside of this, x times x minus 3 is x squared minus 3x minus 4. And then that factors into x minus 4x plus 1. So you end up with this right now. This is what we factored out. This is what we have remaining. Now the x minus 3 to the negative third gets reciprocated down to the bottom, giving you x minus 3 to the fifth. Typical question that you're asked with a problem like this is, what power will the x minus 3 be to the bottom? And the way you get that is just do this. There's already 2 on the bottom. What's the lowest power up here? Negative 3. So when you flip that down the bottom, it's going to make it positive 3, and 2 and 3 is 5. Okay? So that's all you have to do with that. Think of flipping the lowest power one down to the bottom, and that gives you a 5th power on the bottom. But there it is, simplified right here. And now you can do anything you wanted with it. There'd be a vertical asymptote at 3, X-intercepts at 4, and negative 1. And also it has a horizontal asymptote at 0, because the power, the degree of the denominator is bigger than the degree of the numerator. So I believe that's everything. Although not for this section, for this video. We'll come back and do curve sketching next.